Welcome back to another installment on lines and angles. Let's get started. In the figure shown on the right, we know the angle POQ is 55, and you're asked to determine the following angles. So here's how you do it. So we do know angle POQ, which is this, corresponds to 55 degrees, right? So let's figure out angle SOT, which is this angle right here, right? If you notice, angle POQ and angle SOT are opposite each other, right? And opposite angles are equal. So angle SOT is equal to angle POQ because they are opposite angles, right? So therefore, angle SOT would be 55 degrees as well. So this is 55 degrees. From here, you can take more than one course of action to determine the rest of the angles, right? So let's look at angle POT, okay? Now again, even though angle POT is choice C, you can go in any order, and even in fact, you can change, like I said, your course of action to determine the rest of the angles. If you notice, line QT, right, is bisecting line POS, right? Line QT, right, is bisecting, right, line POS, right? Right? That means if you add angle POT, right, plus angle POQ, that'll be 180 degrees, right? We already know POQ is 55 degrees, right? Right? Therefore, angle POT would be it's 125, right? Right, we figured out angle POT. What is angle POR? Well, POR, there's two ways to do it, right? Let me teach you one of the ways. Angle POR is nothing but combination of angle POQ plus angle QOR, right? Angle POQ is 55 degrees and angle QOR is 90 degrees. So that's 145, isn't it? Sorry, 90 plus 55, yeah. 145 degrees, right? Now that means we're left with angle ROT, which is ROT. You're asked to determine angle ROT, which is this angle right here, right? This whole angle, right? There's really two ways to do at this point, okay? You can determine the angle ROS, right? And then add it to SOT and then determine ROT. That's one way, right? Or we know angle POT and angle QOS are opposite, right? That is, this angle is opposite, right? So let me show you both ways how to do it. So we know angle POT is equal to angle QOS because they're opposite angles. We know POT is 125. So angle QOS is also equal to 125, right? So if you want to figure out what is this ROS, that means ROS, angle ROS equals angle, what's the biggest of the two? So that would be angle QOS, right? Minus angle QOR, right? That'll be 125 minus 90, right? That'll be 35 degrees. So this is one way of finding ROS, right? Right? Or another way it would be angle POQ. This is method 1, which I've solved here. And method 2 would be, I'm just showing you more than one way because your brain may register one of these two. So POQ plus angle QOR plus angle ROS, right? That's equal to 180 degrees because this whole angle, this is 180, okay? So we know POQ is 55, QOR is 90, we don't know ROS, that's equal to 180. So 180 minus 145, right? Again, 180 minus 145 is 35. You see angle ROS equals 35. We've established the same angle in more than one method, right? That means angle ROT is nothing but angle ROS plus angle SOT. Basically, if you have a common point in the middle, then that's how you determine which two angles to add, right? ROT contains ROS plus SOT. It's sequential, right? We know ROS is 35 and we know angle SOT is 55. So 55 plus 35 is 90 degrees. So angle ROT is 90 degrees. So did we determine all the angles? We determined SOT, which is 55. We determine angle ROT is 90 degrees. Angle POT is 125 degrees. Angle POR is 145 degrees. And it all makes sense, right? The way where you have a right angle, your acute angles and obtuse angles, they all seem to fit sort of the profile based on, just a rough approximation. You would say this is obtuse, this would be acute. Those sort of predictions seem to match the type of values we have, right? All right, let's continue to the next problem. So we have a line and you have another line that's perpendicular to the first line. So you have two angles, 40 degrees, and you have x minus 90 degrees. You're asked to determine the value of x, right? Because this line is sort of bisecting this line that's drawn horizontally on the plane, these two angles should add up to 180 degrees. So 40 degree plus x minus 90 degree equals 180 degrees, right? This is x minus 50 degree equals 180 degrees. So x equals 230 degrees, right? Right, in the figure above, what's the value of y? We know that figure is not drawn to scale, right? So it's best you work in such a way that these two angles add up to 180. These two angles add up to 180, right? Right, so x plus 3y minus 8 equals 180, right? And you're asked to determine what's the value of y, right? And you have x plus 5x minus 12 is also 180, right? So we can determine the value of x here. So that is 6x minus 12 equals 180. 6x equals 180 minus 12, right? Sorry, 180 plus 12. So 180 plus 12 is 192. That divided by 6 is 32. So 6x equals 192, x equals 32. What you have to notice is, because it says clearly figure is not drawn to scale, please do not assume that 5x minus 2 is equal to 3y minus 8 because they're opposite each other. What I'm saying here is, please don't assume these two are equal because it clearly says figure is not drawn to scale. So you have to figure out some way of numerically solving x and y before you can really make that call. It may be equal, it may not be equal, but please don't assume that they're equal. If you do, chances are you're going to make a mistake, right? So it's very important. You see, they did not say it here, they do say it here. So we know x is 32. So we have to figure out y. So we can substitute for x in this expression here. So 32 plus 3y minus 8 equals 180. So 32 minus 8 is 24 plus 3y equals 180. So if you subtract negative 24 on both sides, that'll be 180 minus 24. That's 156. So 3y equals 156. Y equals 156 by 3 is 52. Now let's see if you had assumed, because this line is bisecting the second line, that these two have to be equal. If you make that, say 5x minus 12 is 5 times 32 minus 2, is that equal to 3 times 52 minus 8? Sorry, 3 times 52 minus 8. So what is 5 times 32? 5 times 32 is 160 minus 12. Is that equal to 3 times 52 is, we know it's 156, right? 156 minus 8, that's 148. 160 minus 12 is 148. They are in fact equal, but we can't make that call because they specifically say figure is not drawn to scale. You might hit the jackpot by making that assumption, but please do not always count on it that they are equal. Okay. It is bisecting, but we don't know if it's bisecting in a way that these two angles are equal. So in this case, they are equal. So if you had made that assumption, most likely you would have got the problem right, but you cannot always get it right. Right, in the figure above, ray OB bisects angle COA. If angle DOB is 11 plus 6 and angle COA is 8x minus 12, what is the measure of DOC? See, even though they say figure is not drawn to scale, they've provided other indications, which is they say OB bisects this angle COA, but then they also say these little, double line. That means these two angles are equal, right? So we know that angle COA is equal to 8x minus 12, right? That means angle COB and angle BOA is nothing but 8x minus 12 over 2, right? That means 4x minus 6, right? So angle COB equals 4x minus 6 and angle BOA equals 4x minus 6. Why do we need this? Because what is that we're asked to calculate? We are asked to calculate angle DOC, right? What else do we know? We do know angle DOB, right? Angle DOC is nothing but angle DOB minus, right? Okay, angle DOB, let's actually write it the other way around so it may make sense to some of you. Angle DOB equals angle DOC plus angle COB, right? And we know we'd want to know angle DOC, so it's be the angle DOB minus angle COB. Angle DOB is 11x plus 6, right? Minus 4x minus 6, right? This is why I highly recommend you use brackets. So it'll be 11x plus 6 minus 4x plus 6, right? So that's essentially 7x plus 12, right? That's angle DOC, right? So how do we find the value? So that means if you notice, well, we still haven't figured out what x is. Until we figure out what is x, then we can't solve the problem, right? That means we have to use the idea of 180 degrees. That means angle DOB is angle DOC plus COB, right? Which means essentially DOC is DOB minus DOC, right? this whole angle here is 180 degrees, right? That's essentially angle DO, right? Angle DOC, or in this case, angle DOB means angle DOB plus angle BOA, right? In other words, angle DOB plus angle BOA is equal to 180 degrees, right? We know this whole angle is 180 degrees, but we know that this plus this is same as the whole thing, right? Which is why we also solve for BOA. So that means DOB is 11x plus 6, right? Plus 4x minus 6 equals 180. So this would be what, 15x equals 180. So x equals that's 12. So now let's go ahead and substitute 12 here. So 7 times 12 plus 12 is 96. Now keep in mind, I'm teaching you this. So I do have the luxury of, expanding my time to incorporate every nuances, but you have to practice. On a test, you don't have this sort of luxury to work everything slowly, one step at a time. You have to do all of these, but you have to do it fast. Now, where does that fast comes from is being able to do more and more problems. And with experience, you should be able to nail this problem in a jiffy, right? Now, if I were to solve this problem myself in real time, I wouldn't be going through all of these. I would make few things in my mind, but I'll be solving this really, really quick, right? So that's how you do problem 3. Here's how you do problem 4. In the figure above, angle ABE is 120 degrees, which is this, as it's shown here. Angle ABE is 120 degrees. And angle CBD, which is this right here, CBD. That's, or you can say DBC, didn't matter. It's 135 degrees. You're asked to determine what is DBE, right? So this whole angle is 180 degrees, right? That means angle, if you can find a way to subtract somehow, then that'll give you this, right? So that means if you add, so what do we need? We need DBE, right? So how do we write it as? So we can write it as, well, essentially, if you notice, if I say, what if I just subtract these two? Well, that will be 15 degrees. 15 degrees is not even one of the answers, right? So clearly that's not the method you want to take. So how better we can write DBE? DBE is essentially, right? We can write it as maybe angle ABD plus angle DBE plus angle EBC. That's one way is DBE, right? This is equal to 180 degrees, right? But unfortunately, if you write it as ABD, we don't have ABD. We don't have CBD as well. So we have to write it in some ways where B is covered. So what if we do ABE, right? So this angle right here, we have to figure out somehow, right? We have to figure out these two somehow so that we can figure out DBE, right? So what if we do angle ABD plus angle CBD, that's 180 degrees, right? So if I call this and I call this X, that means X plus, we know CBD is 135, right? That's equal to 180. So X would be 180 minus 135 is 45. So we know X is 45 degrees. So this now right is 45 degrees. We know that. We don't know DBE. That's what we have to figure out. Similarly, we want to find EBC, right? How do we find EBC? That's essentially angle ABE plus angle EBC, that's equal to 180 degrees, right? Let's call this fraction, this proportion here, y, or this space here is y. So ABE, we already know is 120 plus y equals 180. So y equals 60 degrees. So now we know this is 60 degrees, this is 45 degrees, right? Now we know this as well. So 60 plus 45 is 105, right? So that means angle DBE would be 180 minus 105. Sorry, 180 minus 105. That's 75. So the answer is 5. Now you see, I didn't take any shortcuts. I did my best to work the problem in a way that I'm comfortable with. It may have cost me a little more time, but I'm teaching you. If I were to do this problem myself, then that's a whole different story, okay? I'm doing a lot of this thing in my mind. I'm not even speaking it out. I'm just doing it, right? So the only way you can get good at it is just by practicing more and more problems, right? So this is how you do these problems. Thank you for watching. I'll see you with another video on lines and angles. Until then, bye-bye.